we learned how to use the derivative to find a tangent line to a vector valued function. So the example that we did was r of t is t squared, t minus 1 log t. And so we can compute that r prime of t is 2t, 1, and 1 over t. And we were doing this when t was equal to 1. And so we found that r of 1 was 1, 0, 0. R prime of 1 was 2, 1, 1. So the equation for a tangent line was L of t is 1, 0, 0 plus t times 2, 1, 1. So this is the equation of the tangent line when t is equal to 1. So if we have some curve that's flowing around, this is our description of r of t here. So let's say that this point right here is r of 1. And so it's moving along left to right, let's say. So at that point, there's a direction vector. And so we are finding the equation of the entire tangent line. So this was an example we already did in class. Let me show you just a little bit about how this should match our intuition about what we know from Calc 1 about what the derivative says, that the derivative is the slope of the tangent line. How does slope of the tangent line carry over to, how does this match up with this setting of using the derivative to come up with a tangent line in 3 dimensions? So let's just pick a very easy example in 1 dimension. Let's say, going all the way back to Calc 1, let's say we're thinking about something like y is equal to x squared minus 4. And so, without too much difficulty, well, we know dy dx is 2x. So, when x is equal to 2, we can see y is equal to 0. And dy dx is equal to 2 times 2 is 4. So this tells us that, well, let me graph the function first. So there is the point in question. X is 2, y is 0. So this dy dx right here, this tells us that the slope of the tangent line is equal to 4. So right here, this tangent line, this has slope 4. Now, if we wanted to write this out all the way, we could use point slope form to observe that y minus y naught is 0 is equal to m. 4 is our slope times x minus 2. So if we expand this out, we see that the equation of the tangent line is y is equal to 4x minus 8. So this is all a rather straightforward Calculus 1 exercise. But let's think about how this could carry over into the Calc 3 world. So anything that's in x and y, we could think of this as being in 3 dimensions, where the z component is just going to be 0. So we could think about rewriting this as r of t is t squared minus 4, 0. So this is a vector value function that gives us different points on our parabola here. So note that we essentially just replace t with x. And what is y? Y is x squared minus 4, so y is t squared minus 4 here. And we're staying in the xy plane, so we want our z component to be 0 always. So r of t is just going to be t squared minus 4, and 0. Well, let's see what happens when we take the derivative. R prime of t is 1, 2t, and 0. And let's figure out what happens to these two when we plug in at t is equal to to 0. Sorry, when t is equal to 2, that's when x is equal to 2, which is what we care about. And so we end up with r of 2 is 2, 0, 0. R prime of 2 is 1, 4, 0. And so if we were to use the same method that we had on this slide to write down the equation of the tangent line, we would say our equation of the tangent line, L of t, is the initial point, 2, 0, 0, plus t times our direction vector, 1, 4, 0. Well, what do we notice here? This 1, 4, 0, this is exactly saying that we're heading in the 1, 4 direction, which means for every 1 unit we head to the right, we're heading 4 units up in the positive y direction. So this direction vector 1, 4, 0 is just a different way, and we're just sticking in the xy plane, of writing the slope of the line here is 4. So here we have an initial point, 2, 0, or 2, 0, 0, depending on whether we're thinking of this as being in 2 or 3 dimensions. And then we have, this is our direction vector written in 3 dimensions, but you know that's exactly equivalent to saying that this line has slope 4. So we can see in this case that these two things, that we know that the derivative gives us the slope of the tangent line, but then we can also see here that this exactly matches up the picture we were thinking of this as a vector value function. So hopefully this helps to shed some light as to the connection between things that we know from before in Calc 1 and what we're doing here in multiple variables.